SAFSTOR matters!
Hi, I'm Marty Cohn, Senior Communications Specialist at Vermont Yankee, and welcome to Episode 3 of SAFSTOR Matters, a program that features the activities at Entergy Vermont Yankee plant site. To review, the plant at the end of 2014 shut down, closed, and within a month, all the nuclear fuel was removed from the reactor and placed in the spent fuel pool. Vermont Yankee certified to the Nuclear Regulatory Commission that the reactor had permanently ceased operations and was permanently defueled. A lot of work has been done to transition the plant and the organization to support long-term storage prior to full decommissioning. In this episode, we will discuss the Spent Fuel Management Program with Ken Swanger, Senior Project Manager, Dry Fuel Storage at Entergy Vermont Yankee. Ken, welcome to SAFSTOR Matters.
Thanks, Marty.
So before we begin, just tell us a little bit about yourself. How long have you been at Vermont Yankee?
Okay, I've been at Vermont Yankee since January of 1990, so I've been there for about 25 and a half years. I live in Vernon, a couple miles from the plant with my son and my two Labrador retrievers, Buddy and Otis.
So you've seen a lot of change at Vermont Yankee.
Over the years, yes.
So let's get down to some basics. What is spent fuel?
Spent fuel is nuclear fuel that's been irradiated, typically in a reactor, that's no longer useful for sustaining a nuclear reaction.
And where is spent fuel kept?
Spent fuel, once it's removed from the reactor, it's moved to a spent fuel pool, which is what we call wet storage, and it'll stay there until we transfer it into dry storage, which is our dry fuel storage campaigns.
Now, a lot of people, I've heard it called an asphyxie pad. What does that stand for?
Asphyxie is Independent Spent Fuel Storage Installation. So that's the technical name for the pad and the cask sitting out on the pad.
So is some of the fuel, you said, is in the spent fuel pool, and some of it is already on the pad?
That's correct.
On a pad that was built?
Correct.
And were you involved in those in the previous campaigns to move?
Yes, I've been in charge of all three of the campaigns in 2008, 2011, and 2012 that have moved the 13 cans that are currently stored on the pad.
So, you know, we've heard in a number of public forums, there's been a lot of talk about these campaigns. And one story that we heard was that one of the canisters, the cask, dropped.
Okay, dropped is not a correct term. The first can that we brought out of the pool, we had about 3 foot above the refuel floor, and it drifted down and settled onto the refuel floor. It did not drop.
Oh, so that's just a misrepresentation of what actually happened.
That is correct.
And since that time, I'm sure that we've looked at, because this is something that we do a lot of, we've looked at what caused that and we've made certain corrections?
Absolutely. We corrected it and we've since upgraded that entire system.
Wow, okay. Now, a number of people have also asked, how long can we keep the spent fuel in the pool?
You could keep it there indefinitely if you chose to. It's not as efficient. It's a little more cost effective to put it into dry storage.
Okay, so and when we're talking about the dry storage, will all the fuel from the spent fuel pool, will that fit on the pad that we have?
Unfortunately not. The current pad that we have is an 8x5 array, so there's 40 storage locations. We can set 36 cans out there. We're going to keep 4 vacant so that if we, unlikely event that we ever want to retrieve one of those cans, we can move the cans to pick it up. So there's 36 can go there. We will have 58 total, so we do need a second pad.
So you need to build another pad. What's the process for that?
Well, this is a spent fuel storage installation, so you need in the state of Vermont to go get a CPG, which is a Certificate of Public Good. And that is the Public Service Board evaluates the benefits of allowing this to be built in the state for both the state and the people of Vermont.
And how long does that process take?
We have filed and we expect the CPG process to wrap up in May of next year.
Okay. Now, when we're building the casks that are currently there, what kind of casks are they? Who did those?
Okay, we used the Holtec High Storm 100 system.
That's the casks that are currently on the pad?
That's correct.
And what's the plan for the subsequent?
That's the best system out there for our application, so we will continue. All 58 casks will be the same.
So how did you come to choose Holtec?
Well, back in the days when we started this process, we went through a bid evaluation, evaluated the 5 vendors that submitted. We did a technical evaluation, a commercial evaluation, and when you rolled all that together, Holtec was clearly the winner.
So Holtec, again, there was only a limited number of licensed licensed companies that can build these casks anyway.
That is correct.
Okay, and those are licensed by
the NRC.
Okay, so we chose Holtec. There's been a lot of talk in terms of the Holtec system. Is it only used here in Vermont?
No, it is used in multiple sites across the country and multiple countries across the world.
So, one of the things that, with the Holtec system, it's something that's been tested and approved by the NRC, and clearly we're already using it at Vermont Yankee.
That is correct.
When we used it when we were applying for the first pad, did we have to get a CPG for the first pad as well?
Yes, we did.
And did we have to say that we were using Holtec for the first pad?
Yes, we did. We testified under oath that this is the cask that we're using, the company that's supplying it, did the rigorous analysis, the engineering behind it to say, yes, this is the best for the state of Vermont for Entergy for VY.
So the Public Service Board, in approving the CPG for the first pad, approved the pad, approved the design, and okayed Holtec.
That is correct.
And now we're building the second pad, and basically it's the same as the first pad?
Correct. We're asking for the same approval that they've gave for the first pad. We're going to set the same cask on the second pad.
And is it the same size?
No. The second pad will be a 5x5 array, so there will be 25 storage locations on it.
So we're basically asking for the same thing that we currently have, but it's going to be smaller.
That's correct.
And it's going to take how long?
Well, let's say the CPG process we expect to wrap up in May of next year. We'll start construction immediately, and that pad will be operational in the fall of 2017.
And then what happens after the fall of 2017?
Then we have loading campaigns to load those casks and put them out on the pad.
Wow. And when will that all be done?
It will be done sometime in 2020.
Okay, sounds like we've got a plan. We're going to take a short break right now to hear a word from the Nuclear Energy Institute on dry cask storage. We'll be right back.
Inside the dry cask storage systems, there's a canister that contains the used or spent fuel. We'll use the horizontal storage system, horizontal storage module, as an example of the loading process. The canister inside the horizontal storage module is oriented in a horizontal configuration. The canisters can all hold up to 87 boiling water reactor assemblies or up to 37 pressurized water reactor assemblies. The canister is placed inside a transfer cask, which is then placed in the spent fuel pool. In the spent fuel pool, it goes in an area which we commonly refer to as the cask loading pit. In this image, that's the circular region at the bottom of the picture. Other pools may have a slightly different configuration. Once inside the spent fuel pool, the fuel assemblies are transferred from the racks in the spent fuel pool into the canister, and that's done underwater. Typically, the fuel assemblies are moved after they've been in the spent fuel pool for 5 years or more for cooling. Once the fuel assemblies are fully loaded into the canister, into the transfer cask, the lid of the transfer cask is lowered down, again underwater, and placed in the transfer cask. We do all of these operations underwater to provide biological and radiation shielding for the workers. Once the lid is in place, the transfer cask is removed from the water, and the water inside the canister is taken out and replaced with helium. The transfer cask is then taken out of the fuel handling building and moved to the pad where the horizontal storage module is. Once there, it is connected to the horizontal storage module, and the canister is moved from the transfer cask into the horizontal storage module to complete the process. Now, dry cask storage in either form, horizontal or vertical, at our sites is not a long-term solution for used fuel management. It's simply an interim step until the federal government meets its obligation to remove fuel from our sites for ultimate disposal.
Welcome back. In this edition of SAFSTOR Matters, we're talking about spent fuel management. And at Vermont Yankee, our special guest is Ken Swanger, who is the Senior Project Manager, Dry Fuel Storage at Entergy Vermont Yankee. So Ken, we just heard an overview of how spent fuel is stored. Could you show us how you and your group will move the spent fuel to the pad?
Okay. What we have is a multi-purpose container, a stainless steel 1/2 inch thick, which holds 68 spent fuel assemblies. We take it and insert it into a transfer cask, and this transfer cask is then lowered into the bottom of the spent fuel pool where we load the fuel underwater. Once it's loaded underwater, then we'll put the lid on it to provide shielding. And again, this is all underwater. We just set it there and bring this cask out of there up to the refuel floor where we will weld the lid, drain all the water out, blow all the water out, dry it so that it's dry, backfill it with helium, then weld the ports where we perform those functions. So now it's a completely sealed stainless steel container. Down on the ground floor, what we call our 252 elevation, we've moved one of the storage containers that so we will take, and before we put a mating device on that, which has a trap door, which once we sit down will allow us to take the lid off of the bottom. So we will do this, lower it from the refuel floor down into what we call a stack-up position. We'll lift this a couple of inches.
When you're saying on the refuel floor, that's how far?
That's 345 elevation, and the ground floor is 252 elevation.
Okay, so we're bringing it down.
We'll pick it up just a little, open this trap door, and then you can see we can lower it into the storage module.
Okay.
We'll drop the rigging down. We'll take the transfer case back off. We'll close the door of the mating device, remove it. We'll put the lid of the high storm on, and then we take that and set it on the pad. That's it.
Okay, so so as we're looking at this cask, so some questions. First off, how thick is this cask?
Okay, this storage module has a 1-inch outer carbon steel ring and a 1-inch inner carbon steel with 27.5 inches of high density concrete in between it.
Now, high density concrete, what's that?
That is heavier and thicker to give us more shielding.
Okay, so and then and how tall is the cask?
It's about 18 feet.
Now, how heavy is that?
It's as it sits on the pad, fully loaded, is about 200 ton.
200 tons. So how do you move that?
We have a special vehicle called a vertical cask transporter. It's a tracked thing, something like a tank that comes in and connects to the top and moves it at a very slow speed.
Now, I see there were these, it looks like vents at the bottom and the top. What do those do?
Well, that's the function of the storage module, is there's vents at the bottom, vents at the top. Now, the completely enclosed fuel that's in the stainless steel container transfers heat by the helium to the walls of that. Heats up. As air heats up, it rises, comes out the vent. You pull cooler air in the bottom, so it's a chimney effect sitting there with no moving parts.
So once the cask is moved, and how long does it take to move it?
From picking a cask up to setting it on a pad is about 5.5 days around the clock.
5.5 days around the clock. All right. So then it's sitting on the pad. So, and right now there were 13 casks already sitting on the pad. Is there some kind of monitoring device? What do we do once the cask is on the pad?
Okay, once a month we come around and we have bullseyes painted on this at the middle and a third of the way on each side in the 4 quadrants. We'll take a monthly survey reading to make sure that nothing has changed. And every day, twice a day, once each shift, we monitor the temperature, compare it to the temperature that's coming out the top vents to an ambient temperature, just to see if there's been any change.
So, and this is something that's happening on every day, on a regular basis?
The temperature is twice a day, every day. The radiation readings are once a month.
So when you say radiation readings, what are we talking about for radiation?
On contact, we're reading micro rem. Now, when you work in the nuclear industry, you're used to millirem, but a micro rem is 1,000th of that.
1,000th of that. All right, so sorry, being a non-scientist here, or non-engineer, can you give me something that I can compare that to? Like, what does that mean? Like, if I got in an airplane.
If you got an airplane in Chicago and flew to LA, you would get 390 micro rem per hour in the plane. So a 4-hour flight, you would get what, 1,400, where you're getting 50, 60, 70 on contact from these.
Unbelievable. So it's a safe thing that's being monitored, and in terms of that constant monitor, let's say if magic wand, let's say the Department of Energy got its act together and could start removing spent fuel from Vermont Yankee. What do they do? They have to take the whole cask? I mean, how is this?
What you would actually do is take it out of this storage module, this completely welded stainless steel canister, and put it into a shipping module, which is not unlike this, but lighter. And it would ship on a rail car in a horizontal position with impact limiters on each side.
So in the construction of this dry cask, you already figured out in terms of the intermodality how you would be able to eventually transport it somewhere else. That's correct. So that's all part of the system.
Begin with the end in mind, yes.
So something else that you had said was there were 13 dry casks already on the pad. So how many spent fuel assemblies are on the pad right now?
Well, there's 68 in each of those, so there's 884.
And so how many spent fuel assemblies are in the spent fuel pool?
There are 2,996 left to load.
200. So when you load all of these assemblies into the 58 total dry casks, it's going to be somewhere around 3,000, let me do the quick math, 880 spent fuel assemblies. Now, when all those dry casks are on the pad, does that represent all the fuel that Vermont Yankee has?
For 42 years, we generated 3,880 spent fuel assemblies, which will go on 2 pads of a combined length of about 215 feet by 76 feet. And that's the total storage area of our nuclear waste.
So just so I can get a picture in my mind, some other form of energy, what would that represent? 42 years of producing.
Well, if anybody's been around a fossil plant that burns coal, you can't imagine what 42 years of ash looks like in the ponds and everything. So for waste disposal, the 215 by 76 area is ridiculously small.
Now, once these 58 casks are on the pads and they're being monitored, you said, there'll still be people monitoring. Is there security involved in any of this? I mean,
yes, we have a security force. This is special nuclear material, so we have to comply with federal law. So there is a security force that protects these casks.
And in terms of, I know Vermont Yankee does a lot of drills in terms of emergency planning. Is there planning that's gone into the security for these two pads?
Absolutely. They practice that at regular intervals.
So the $64,000 question that again we're getting a lot is, how much does this spent fuel management program cost?
Okay, we've created a budget of $368 million. $143 million is to build the pad, buy the cask, load them and set them on the pad. The other $225 million are for the operations of the pad.
So is that what the Nuclear Trust Fund, that's what we're going to use for the buying of these casks and everything?
No, we're not. We are funding this, Entergy is funding it through some lines of credit. And after we've set this, then we will turn around and sue the Department of Energy for failing to honor their obligation for the contract, recover that money, and pay off the lines of credit. That way we don't impact the Nuclear Decommissioning Trust, which will allow it to grow faster and decommission the plant earlier.
And then that $225 million that's left, the cost that's left, that's something that we would recover as well?
I'm not sure that we can that we are planning on covering that yet. We'll have to look and see in the future.
But the money that, in terms of the DOE, what are we talking about in terms of time frame? Do you have any idea of how long do you think these casks can stay on the pad?
Well, those casks will be there till the DOE takes them, right?
And do we have any idea? Is there any thought as to when that might happen?
We currently estimate that we'll start picking fuel up from Vermont Yankee in 2026 and be completed by 2052.
But during that entire time that they're sitting in these casks, this is being monitored, there's security, and we feel that this is the best option in terms of the spent fuel management.
Absolutely.
So Ken, I have really one last question for you, and this has come up a lot. Given your experience, how safe is it to move the fuel from wet to dry?
Okay, it is a lifting and rigging evolution that's going on essentially every day somewhere in the world. We've done it here, 13 casts. We'll do it 45 more times. It's safe. We do have Vernon Elementary School across the road. I believe it's really safe because my son was in school the year we did the first campaign. So I'm comfortable. You do need to take precautions, know what you're doing, but it is an act that happens somewhere in the world every day.
And we also have the experience to do it safely and to do it right.
As history showed us, yes.
Thank you, Ken. Is there anything else anything else you want to add to this?
Nope, I believe we covered it.
Okay, great. Well, thank you, Ken, for being on the show. I also want to send a special thanks to Dennis Cordell for writing the original music that you're hearing for the show. You're probably going to be humming it the rest of the day. I also want to thank Sarah Burnap, who is behind the scenes doing all the magic. And a special shout out to all the folks here at BCTV. They have just been a pleasure to work with, and quite frankly, it's been a lot of fun to do this. Our next episode will discuss the economic impact of the closing of VY. We're going to be hearing from representatives from regional planning and some academic folks who've done some incredible studies. So it should be a really interesting show. For all of us at Vermont Yankee, I'm Marty Cohn. Thanks for watching.